Alright, so today we're going to talk about something called arc measures. And we got a little bit more vocabulary to talk about today. The first thing we're going to talk about is central angle of a circle. And what that is, it's an angle whose vertex is at the center of the circle. Center of the circle, central angle. Should kind of make sense. And what that will look like, so if we have a circle here, and we have our center, and we call it that angle ACB is a central angle because the vertex of the angle is at the center of the circle. So angle ACB is a central angle. Now, we have things that are called minor arcs, semicircles, and major arcs. So the math definition of a minor arc probably doesn't make a whole lot of sense. I think it's easier to look at a picture. So if we have a circle, and we'll use the same one from above, with A, C, B, the minor arc is less than a half circle. So this would be your minor arc AB. So we would call that minor arc AB. And then we have a little symbol, like an arc symbol, on top of it. So this is a minor arc. Now a semicircle, if we have most of you probably know what a semicircle is. It's a half circle, and it can go either this way or this way. So we would say semicircle DB, and the arc symbol over top of that. Now a major arc is going to be bigger than half the circle, or 180 degrees. A full circle, so semicircle is half of it, so 180 degrees. A minor arc is less than a semicircle, so less than 180, and then a major arc is more than a semicircle, so that's got to be more than 180 degrees. So what that will look like, I'm going to draw a better circle. So if we still have our A, B, and instead of going this way, we have a third point here, and that tells us that it's going to be the major arc, that third point. And then we go in this direction. So we would say that this is arc, so the arc symbol, A, D, B. Adding that third letter tells us that we're not going from A right to B, that instead we're starting at A, we go to point D, and then to point B. So that's how you can tell that it is a major arc and not the minor one like we had up here. So a little bit more of the rules that we're going to deal with. So you guys know that the entire circle is 360 degrees. And the measure of the minor arc is the measure of its central angle. So the arc measure and the central angle are the same, and minor arcs are always less than 180 degrees. So what that looks like, if we're trying to find the measure of arc AD right here, we need to find the measure of this angle right here, ACD. Well, if the whole circle is this half circle is 180, and this part's 135. Right here has got to be 45 degrees because 45 plus 135 is 180. So since the measure of the central angle is 45 degrees, the measure of this arc is also 45 degrees. Now the measure of the major arc is a difference between 360 and the measure of its related minor arc, and it's always more than 180 degrees. So if we look at arc, it says ABD, so we have A, B, D. Okay. Well, previously we have already figured out that the minor arc here was 45. So if we do the whole circle 360 minus this part that's 45, that will leave us with what is left over, or 315 degrees. Another way you could have done that is said, okay, well, you know a semicircle is 180 degrees, so you could have done 180 plus 135, and you would have gotten the same thing. So the next bullet point, the measure of a semicircle is 180 degrees. So any semicircle, we have A, D, B, so A, whoops, A, D, B is a semicircle, so that is 180 degrees. All right, let's look at the next page. It says, name the arc shown in bold and tell whether it's a minor arc, a major arc, or a semicircle. So the bolded arc is right here. So that is arc AB, and that is a minor arc because it is less than 180 degrees. It's less than a semicircle. Letter B, the arc here in bold is ADB. So this is a major arc because it is larger than 180 degrees, and we would say that that is arc ADB. Or you could call it arc BDA. It's the same thing. And then the last one is right here. This is a semicircle. It's half the circle, and you know that because this is a diameter. So you could go in either direction. You could call this arc PQ or arc PSQ, and it is a semicircle. All right, now let's look at example 2. Find the measure of each arc of circle C, where AB is a diameter. Also tell whether the arc is a minor arc, major arc, or semicircle. So DB is right here, this arc. So it's the same picture we had on the front. So DB is 135, and it is a minor arc. Now, arc DAB, DAB, DAB. Okay, well, that's going to be the 180 because this part from A to B is 180. And then this part right here, well, the whole circle is 360, so if we do 360 minus 180 minus 135, that gives us 45 degrees, or you could have done like we did in the previous page, 180 minus 135 to get 45. So now DAB will be 45, this part right here, 45, plus this part, 180, which will give us 225. So it's 225 degrees, and it is a major arc. And then ADB, just like on the previous page, ADB is a semicircle, so it's 180 degrees. Now, adjacent arcs, they're adjacent if they have a common endpoint. If they have endpoint. So like AD and DB, we have AD right here, and DB, they're adjacent because they shared point D. So AD and DB. So that brings us to the Arc Addition Postulate, and it's pretty trivial to come and talk about this, but at least now it's somewhere in your notes. Basically, that what it's saying is what we did up here. That, all right, these two arcs, AD, and DB, if you add them together, you get the whole arc, ADB. That's what it says. So it is the sum of those two arcs. So ABC, that was the measure of arc AB and the measure of arc BC. So it's kind of like that angle addition postulate where we talked about at the beginning of the year, that if I have a line and I know that this part is 17 and this part is 19, that you add them up to get the whole distance. So that's what this is pretty much talking about, but it's referring to arcs, not segments this time. Alright, so let's look at example 3. So we have a circle graph here, and the numbers on the outside, that's just part of the survey results. So don't get confused by those numbers 17 to 44, 15 to 17. Those are just the results of the survey. When we're looking at these problems, the measure of arc RU, okay, we're looking at the central angles. So RU goes from R to U. So we want to add up these two central angles, 60 plus 80, which is 140 degrees. And then arc RT will start from here and go to T, and that's going to be 100 plus 30. Now notice for that one, I didn't go in this direction. I didn't go the other way because there was only 2 letters. That tells me that I want to take the shortest route and not go all the way around like that. Now RVT means I'm going to start at R, go to V, and then go to T, instead of going R to T like that. So then that's going to be 60 plus 80 plus 90, and that's going to give us 230 degrees. And then finally, the measure of arc Ust. So here's U, then we're going to go to S, and then T. So notice I'm not going to go U, T, S, because that's not the order that we have right here. Ust means I'm going to go from U to S and then to T. Now, how I would do this one is instead of adding up all these numbers, you see that it's almost the whole entire circle except for this 90 degrees. So instead of adding up those four numbers, I'm going to do 360 minus 90, and that's 270 degrees. Now, you could have added up all those numbers and you would have gotten the same thing. This is just a little bit faster. Alright, now the last one, I'm going to draw the picture and then I'm going to have you guys try this on your own. So we're going to draw a picture, and it says we have E, and it says AC and BD are diameters. Okay, so AC and BD. Now you don't have to draw them exactly like this. It's not really telling us where to draw them. Let's make this one a little bit better. B. And it's telling us that the measure of arc ACD, so ACD is 316 degrees. So this whole thing is 316 degrees. Okay, so pause the video and try this, but remember that semicircles are 180 degrees. So that might help you out for this problem. Okay, so pause it and see what you come up with. Okay, so the first thing I would have done is said, okay, if they're telling us that this blue arc is 316, that means AD right here has to be 360 minus 316, or 44 degrees. Okay, if that's 44 degrees and AC is a semicircle, okay, because we have a diameter here, this arc down here from DC must be 180 minus 44, or 136 degrees. Now, I know it doesn't look that way, but that's just because that's how we drew the picture. Like I said, always go by the math. Then we can break out vertical angles. So if this is 44 degrees, that means this angle is 44, which means this angle is 44, which means this arc right here from BC is also 44 degrees. And then similarly, this arc right here has got to be 136 degrees. So now we can go and answer these questions. Arc AD, well, we have that as 44 degrees. BC, we have that as 44 degrees as well. Arc BCA, so BCA is going to be this 44 plus this 136 plus this 44, or you could do 360 minus what we haven't used, minus this 136 over here. It doesn't matter what you do. So that will give us, we can do 360 minus 136, and that will give us 224 degrees. And then DCB, DCB Well, that's a semicircle, so that will be 180 degrees. So this has a lot of adding and subtracting, which I know you guys are great at. It's just you really have to draw a picture, label, and trace with your pencil to see what we are trying to figure out. So if you need to rewatch this, pause it, help go back and review things, and let me know if you have any questions. Bye.